Hello everyone, hope you're doing well. In the previous talks, we talked about different kind of data structures and also where they use typically and some of the things about them, like about how their complexity is calculated and also like where to use them, some of the common use cases around using them. So after covering the basics of them, data structures, I'm planning to go a little deep dive on each of them one by one. So in today's session, we'll be picking the stack. And as we know, this is the simplest one when we talk about data structures. So we'll be talking about what are different things that are important to know when we talk about data stack and also the different algorithms which make sense or which are required to understand different operations of stack. Okay, so let's deep dive. So we briefly touched upon on this topic in the previous sessions that it follows last in first out LIFO. Any element that kind of goes into it, just keep adding on the top. So any members that inserted last would be also be going first. So it is like, you know, it is like you can imagine a box and you keep adding the different elements on it, and it is open at just top, at other side it is closed. So as you keep adding the elements, and once you when you want to remove, you will be removing the one that added in the last, because that's what the one end will tell you. So this is what the like how this stack kind of works at a high level. Coming to different operations of it, so typically it has two major operations, like you can say push and pop. Like push means inserting the elements, pop is, as the name suggests, is like removing, taking out. Other operations can also be used, like making it empty, like clearing it up. Some of the properties that are also important in the context of stack is, like for example, peak. Peak will give you the element which is at a top level, or which is like newly being added, right? So that will peak us. Is empty. So this is a property that will scan or traverse over your stack and check it out if it is empty or not. So it will return you like true or false. Again, one more property which is used in as a support to other algorithms, so like is full. So it will again check whether whatever size you have defined, whether you have crossed that size or not. Let's go further on them, how they looks like. So how it works, think about it. So as we talked about that push and pop, so how, if you start visualizing it technically, so you can as you can see two boxes, why two boxes, so that you can understand this push and pop, right? Like one by one, like as in the same screen. So you keep adding the elements, so it will be like stacked up. So and its popping is something taking out one by one from top, of course, because one end is anyway closed. So that is how you can visualize it, that how the elements insertion and removal happens in stack. Let's talk about now complexity. We briefly touched upon complexity, that we have typically two kind of complexity majorly. So one is time complexity and other was space complexity. Time complexity, of course, is most important because it talks about that how fast the operations on any of the data structure is, and that's what we care most. Any developers care most on the performance of it. Of course, space complexity also matters sometimes when you're running out of resources and and of course you don't want to consume so many resources. However, if you ask me to compare that which matters most for most of the developers, so it's the time complexity, because it is directly connected with how fast operations on how fast basically any data structure performs those operations. So coming to stack on those things, so as you can see there, stack can be implemented by either by list or by also by array, and in linked list, of course, you can see that both insert and delete are like O1. O1 can be considered as the fastest operations, right? I can't think of any other operations that is faster than O1. It is like constant time. Array, if you try to compare the same with array, so delete is of course same. However, insert is generally is ON, right? Then ON is basically number of elements, how much you have, and that is proportional to that. However, this amortized time also. So what is amortized time? Let's try to understand that. So it is one of the term used in measuring the complexity, and it is basically over time the realization was that we should not be depending on just one operation to measure the complexity. Rather, we should look at multiple operations and look at a kind of aggregate time that it takes to be fair on that particular algorithm. So sometime it may be slow depending on the number of data, and sometime it may be faster. So if you look at amortized time complexity, then it is close to 1 only. So what it means that both insert and delete operations, either performed with a linked list or array, gives you almost similar kind of complexity. And here we're talking about time complexity. Okay. Now let's review the algorithms on different operations that we can be performed in the stack. Just to tell you that in this session we are talking about algorithms. In the next we'll be also talking about implementation. So we'll have real implementations based on these algorithms, and we'll see how to actually code for them. In this session we are just talking about the algorithm so that you understand at a conceptual level, so that when we talk about implementation of it, when we look into the real code, you're clear on that. So the first one, let's start the simplest one, that is a peak. As we spoke in the previous just few minutes back, that peak gives you the element that is in the top of the stack. So as you can see, the procedure has just one real statement in the code, and that is returning the top element of the stack. So for example, you inserted 1, 2, 3, 4, 5. So and let's say this was a sequence that first you inserted 1, then 2, then 3, then 4, and 5. So this algorithm will give you 5 because 5 would sit on the top. Okay. So that's how this peak operations you can define the algorithm. Other is algorithm that is also important to check, and it is basically when we talk about push and pop operations. So some of these algorithms are useful as a supporting algorithm to check whether, for example, if you want to insert in a record, and of course you want to also check whether the stack that I'm going to insert the record has some space or not, right? So in those cases, these algorithms really helps to check whether a stack is full or not. So how to check if stack is full or not? What is the algorithm of that looks like? So as we look into the previous slides, if you look at we have basically we can here, right, we talked about that either we can implement the stack with array or linked list, right? These are main common ways to implement that. And also we know that in array we got to define the size of it. can't be, it can't be basically what do you call dynamic in nature. So if it is an array, we're talking in the context of array only here. So we need to define the max size of array. So let's say that max size you define as a 10, right? So if it is a 10 and you are inserting, like you are done with 10, and suppose that you are trying to insert 11th member on that stack, so it should return the false, right? Because there is no, I would say there is no place left for any member to be inserted again, because the size was 10 and you already inserted or pushed the 10 10 elements. So the is full is like if your top, because top is kind of running counter, you can say. So it is capturing that what is my max size at this any given point in time. So if it is already equated to the max size, the size of the stack that is defined previously, so it will say that okay, it is true, it is full. And if it is not, if max size is still bigger than the top, means you have more place, or you can say more room for any members to be inserted, then you will return false. So that is about the is full. Look at is empty. That is again one useful property that is used as a support, you can say, properties or support algorithms in the major operation that we call push and pop. So what do you tell? How you define the algo? So so what happens, right? As we know that when we are kind of doing push or pop operations, so if it is empty, so as we know that indexing, right, on any array starts typically from 0, whether it's a C, C++ or C#. So if indexing is starting from 0, then we should be having something below 0 to make sure that it is empty, right? Otherwise, if you make 0, then it may be the misleading thing or confusing things. So what we check that if the top is less than here, it is written as 1, but it is when we implement it, because the algorithm, it is algo, because algo is irrespective of any language, but when we implement it, we'll be checking against that if it is less than 0. So if it is less than 0 means it has, top is still at initial state. It has not, it doesn't have any elements. So if it is less than 0, then it will return true. If it is not, if it is, it is, suppose you have got one element, so it will be, top will be 0, so means you got one element, like that. So if it is less than 0, like in the implementation, it will be true, otherwise it will be false. Coming to push, so push is one of the major operation, and if you pushing is not inserting. So how to define that the algo? So of course, when we try to insert it, you should be checking that whether stack is full or not. If it is, I think how to check that is full, we already discussed on that. So if it is full, of course, you will not allow. And if it is not, then you will proceed further and you will increase the top. So if top is suppose -1, that is the initial state, you will make it as a 0, and you will insert member on 0th element, 0th position. So that is how the push will be. Okay. Coming to pop, so pop is what? Taking out or removing. So how to go about it? So in pop, you will check that if it is already empty, of course, there is nothing to pop. So if it is empty, you will return and you will not do anything. Otherwise, you will take out the top element and you will decrease the counter. That's how this pop will work. Okay. As I said, in the next session, we'll be talking about the implementation, or we'll be going into the code and we'll try to understand how this looks like. Thanks for your time.